about the most important topic in physics, energy not conserved. Many students not understood why energy not conserved, because according to the energy conservation principle. What is energy conservation principle tells us? The energy is always conserved. Energy not created, not destroyed. It can be transformed from one form to another form, and the total energy in the whole universe is remain constant. Total energy in the whole universe remain constant. This is according to the energy conservation principle. So the topic is strange. Energy not conserved. Yes, you listen carefully. Energy not conserved, I say, and it confusing many of the students. It confusing create the many confusions. But the energy not conserved. This topic is different from the energy conservation principle. Both topics are different. Remember that both topics are different. Energy conservation principle difference, and energy not conserved of energy is not conserved. This is a different topic. We speak about in the energy conservation principle. We speak the energy of the system plus the energy of surrounding. We consider in energy conservation principle energy of the system plus the energy of the surrounding. But energy not conserved, in that topic we only consider the energy of the system. We not speak about the surrounding energy. We only consider the energy of the system. I told you a very simple example. If the body is fallen, if the body is fallen, first thing is that when energy not conserved, there are two important cases. There are two important cases when the energy not conserved. First, if we not isolated the system from surrounding, if we not isolated the system from surrounding, then the system interact with surrounding, and in that case the energy of the system is not conserved. Energy of the system is not conserved. And second, that if there is non-conservative forces like the frictional force, if there is a frictional force, non-conservative forces, in that also case the energy of the system is not conserved. I give you to a simple example. If we take the hot water in the glass and the glass is open, we not close the glass, what happens? The water vapor go to the surrounding, and the temperature of that hot water gets decreases. That is the temperature of the system will be decreases, energy of the system is decreases. Second, everyday life example, that if we drop the anything, if we drop the ball toward the earth, what is happen? The ball or the body undergoes the friction with the surrounding air. If we drop anything from the height h, then that system undergoes the friction with the around air, and in that case it created the heat energy as well as sound energy. The falling body undergoes the friction with the air, and it creates the heat energy and sound energy. So the kinetic energy of the falling body, decreases, and that energy converted into the heat energy and sound energy, and in that case the energy of the falling body not conserved. Remember that if we drop the body, the kinetic energy of the body goes increases, but at the same time body undergoes the friction with the air, and it can create the heat and sound energy, and the energy of the falling body not conserved. Energy of the falling body not conserved. We speak only about to the body and not of the surrounding air. We not speak about the energy of the surrounding air. So this is a two basic difference. In the energy conservation principle, we speak energy of body plus energy of the surrounding, and it can create the universe. It can create the universe. So according to the energy conservation principle, energy not created, not destroyed, it can converted from one form to the another form, and the total energy in the universe is conserved. Total energy in the universe is remain constant. Vice versa, if we only consider the energy of the system, only system, we not consider about the surrounding. If we only consider energy of the system, and we not isolated the system from surrounding, and if the system can undergo the frictional force, in both cases, if we not isolated the system or the system undergo the frictional force, in both the cases the energy of the system is decreases, and it can convert it into the heat energy, sound energy, and other form of the energy. So this is a basic difference between the two of them. Many students confuse. We listen that energy is conserved in the whole of the universe, energy get conserved, but what is the topic? Energy not conserved. So the both topics are different. We only speak the energy not conserved of the single body, and energy conservation principle apply for the body as well as the surrounding. So share this simple thought, many students remove the confusion of the many students. And if you miss the part, then go to the my YouTube channel and you can see from the starting. So what is the basic difference between the energy conservation principle and the energy of the body is not conserved, energy of the system is not conserved, and if there is energy of the system, yes, this is true that according to energy conservation principle, remember that there are various type of the energy: heat energy, nuclear, kinetic, potential in the surrounding, large electromagnetic energy, large type of the energy, heat energy. They can be converted from one form to another form. Yeah, this is a possible, but it is not possible to destroy them or to create the energy. Not possible destroy the energy or create the energy. This can use the energy conservation principle. So if you miss the part, go from the started and share this talk to the maximum student and remove their confusion. Share. Thanks.